Okay, so this is the unit circle you can expect to be given for the first exam, and you'll probably actually have this for quite a few exams to help you to fill out. So on this first exam, we're going to focus just on degrees, and so I'm going to go ahead and kind of show you how to fill this out. So we know a circle is 360 degrees. So what we'll do here is we'll start out. See, one second. So here we're at 0 degrees, and so if you go 1/4 of the way, this would be 90, and then 180, and then we'll go down here. This will be 270, and then you're back to 360. Okay, so I think we all know that this one would be 45 degrees right here. And so 45 to 90, then add another 45. So I'm just trying to give you little tips on how to remember how to fill this out. And so if we kind of go in a pattern, it won't be too bad. So this should be 225. Okay. Then we're back to 270, and then we'll add another 45 to that. And that should get us to 315. Okay, so then what we'll do here is now we'll look at going by 30. So 0 to 30, then to 60, 90, then we're going to go to 120, then we'll go to 150, then we'll go to 180, then 210, um, and then we'll bounce over to 240, then 270, then to 300, and then to 330. Okay, so now that we have all the degrees written here, and we'll look at radians in a different video later on. Now we want to go ahead and fill out our trig values. Well, basically what we're going to do is we're going to do our x and y values, which essentially, because of the unit circle, the radius is 1. Basically, your your x and y value are going to be synonymous with your cosine and your sine values. Okay, and then from there we'll fill out the rest of them. So this little chart right here, that's going to be what we're going to look at is just the first quadrant, and we'll use reference angles to refer to this for our other angles inside the unit circle. Okay, so really, really just if you fill out the first quadrant, you should be able to refer back to it. You just have to make sure you know your signs for each quadrant, and we can talk about that. Okay, so right here at 30 degrees, you're going to have square root of 3. Oops, try to write that a little bit clearer. Let's see, do this in blue. Okay, so we're going to have square root of 3 over 2, and then your y value is 1/2. So that's actually going to be your sine and cosine values right here. Okay, but we'll fill this out in a moment. Then at 45 degrees, your x and y are both the same. So your distance from the origin right here, your x, and then your y, they're both the same. They're both going to be square root of 2 over 2. Okay? And then at 60 degrees, what happens is it flip-flops from your 30-degree angle. So now your x length here is going to be 1/2. And your y length is going to be square root of 3 over 2. Okay, so I guess I'll fill out the other ones because they're actually, it's pretty simple once you get the first quadrant, because what you can really do is kind of reflect these values over here. So see, the 60 degree is going to reflect over to the 120. The only difference is that now your x value is negative. Okay, so see, from the origin moving over, my x value is negative, my y value will stay positive. So that's really going to be the only difference. I'm just going to reflect these over here. So my x value is going to be negative 1/2 instead of positive, and then my y value is still square root of 3 over 2. And that's going to be the same case on all these. It's just all my x values are now negative. And then same thing here, negative square root of 3 over 2, and then positive 1/2. Now you can do the same thing going into this quadrant 3. You're going to reflect 150 down to 210 and 135 down to 225 and so on. You can just reflect it across the x-axis. And so what's going to happen here is your x value is not going to change, right? Because you're just moving down over here. But what does change is your y is going to flip-flop from being positive to now being negative. So that's what we're going to do down here. So we'll start right here. So my x value is still negative square root of 3 over 2. Now the y value will be negative 1/2. And then we're going to do the same thing right here. So this will be negative square root of 2 over 2. And then the y value is also going to be negative square root of 2 over 2. And then we'll do the same thing with our last one right here. So let's see, we're going to have negative, oops, pen's giving me some trouble. So we'll have negative 1/2, and we'll have negative square root of 3 over 2. And then just like we've been doing now, I can reflect them over here. I could go back to quadrant 1 and reflect if I want to. But see, this point, when I reflect it across, my x value goes from being negative to being positive, but my y value doesn't change. So let's see, this will be, positive. This will be positive square root of 3 over 2, but then the y value will stay negative 1/2. And then positive square root of 2 over 2, and then this one will stay negative. Okay, and positive 1/2, and then my y value is still negative square root of 3 over 2. We can talk about the axes in a moment. Those are pretty basic. They're either 1, 0, or negative 1. So let's see. So my x value is 1, y is 0 over here. X is negative 1, y is still 0. Down here, x is 0, y is negative 1. And then up here, my x value is 0, my y value is positive 1. Okay, so now filling out this for quadrant 1 is going to really help you. So, and I'll show you how in a moment. So let's see, sine of 30 refers to the y value. Let's see, that'll be 1/2. 45 degrees will be square root of 2 over 2. 60 degrees will be square root of 3 over 2. And then cosine will go in the reverse order, so it will be square root of 3 over 2, square root of 2 over 2, and then 1/2 right here. Okay, now tangent is the ratio of sine and cosine. So if I were to divide these right here, and I'll just go ahead and show you over here. So if I want to do tangent of 30 degrees, sorry about this, I need to get a new stylus pen. It keeps giving me some issues here, but okay. So so we're going to take that ratio. So you're going to have 1/2 over the square root of 3 over 2. And so we'll do a thing called keep. So we're going to keep the 1/2, change the division to multiplication. So we're going to have 1/2, and we're going to change it to multiplication, and then we're going to flip the bottom. So keep, change, flip. So then we'll get 2 over the square root of 3. And so what will happen here is the 2's can go ahead and cancel out, and we're left with 1 over the square root of 3, but we have to go ahead and rationalize that. So what we'll do is we'll multiply by square root of 3 over square root of 3, which basically essentially I'm multiplying by 1. And so I'll end up with square root of 3 over the square root of 9, and the square root of 9 will give me a 3 right here. Now don't try to cancel those out because one's a radical, one's not, so just be careful about that. So we're going to get square root of 3 over 3, okay? For 45 degrees, that's pretty simple because when you divide them, they're both the same, so you know, anything divided by itself will equal 1, so we'll go ahead and put a 1 there. And then for 60 degrees, this one's a little bit easier to do, and once again, I'll just go ahead and do it on the side of my paper. So let's see if we want to do tangent of 60. This one should work out a little bit nicer than the first one we did. So square root of 3 over 2 divided by 1/2. And so once again, we'll kind of do that keep, change, flip. So we're going to have square root of 3 over 2, and then we're going to multiply it by 2 over 1. And so the 2's cancel out like the other one, but what's nice here is you're just going to be left with square root of 3 over 1, or just the square root of 3, so we don't have to rationalize on this one. So we'll go ahead and put square root of 3 right here. Okay, now you know how sine went from 1/2 to square root of 2 over 2, square root of 3 over 2, and then cosine went in the opposite order? Well, that's what's going to happen with cotangent, because cotangent's just the reciprocal of tangent. Okay, so you would be, instead of doing 1/2 over square root of 3 over 2, you would be doing square root of 3 over 2 over 1/2, and we've already done that over here. So you don't have to repeat it. So everything's just going to go in the reverse order from tangent. So we're going to go from, let's see, we're going to go square root of 3 here. Sorry, it's acting up on me again. Square root of 3 here, and then we'll have a 1 here, and then on the back end we'll have square root of 3 over 3. Okay. Now the secant is going to be the reciprocal of cosine. So on these first couple, we'll have to do a little bit of some rationalizing. So when I flip this, it's going to be 2 over the square root of 3. Now, I'm kind of running out of room, so I'm just going to kind of explain this verbally, but what I'm going to do here is multiply the top and bottom by square root of 3. So I'm going to get 2 square roots of 3 over, and then when I multiply the bottom by square root of 3, I'll get square root of 9, which is 3. So this should be what I get right here, 2 square roots of 3 over 3. Okay? And it's going to be similar right here for the secant of 45 degrees. So I'm going to go ahead and take the reciprocal here. So that'll give me, let me change colors. So what we'll do is we'll have 2 over the square root of 2. And then when I rationalize it by multiplying the top and bottom by square root of 2, I'll end up with 2 square roots of 2. Actually, I'm going to run out of room, so let me see. I think I can fit it over here and show you. So I'm going to have, let's see, 2 over the square root of 2. And so I multiply the top and bottom by square root of 2. So I get 2 square roots of 2. And then on bottom, I'll have square root of 4, which will become a 2. And then what we can do is cancel the 2's out. Okay, and then I'm just left with square root of 2. Okay, so all I did was I took the reciprocal of this, rationalized it, and then I was able to simplify by canceling those out. And then luckily the last one's pretty simple. The reciprocal of 1/2 is just going to be 2. And then same thing here. So for the cosecant, just like what we saw with all the other ones, they're going to go in the reverse order. And so it's the reciprocal of sine. So this is, the reciprocal of 1/2 is going to be 2. The reciprocal of square root of 2 over 2, we just did that on the side of the paper. That'll be square root of 2. And then the reciprocal of square root of 3 over 2, once you rationalize it, you should end up with 2 square roots of 3 all over 3. Now don't try to reduce those 3's though. Okay, we could reduce the 2's because neither one of those were a radical right there. So this took me, about 13, 14 minutes to fill out. The thing is, once you fill it out, you'll just use it as a reference and it will help you answer quite a few questions. So it's going to be a lot faster than trying to answer each question individually and trying to derive the ratio that you're looking for. So I just want to do like 1 or 2 examples of showing how this could be useful. So if I ask you for the secant of, let's say, 240 degrees, okay, what you can do here is, so 240 is right here, what you can do is to get back to home base, which is going to be quadrant 1, okay, you're basically going to reflect over here and then reflect back up. So its reference angle is 60 degrees. So what you can do is you can look at secant of 60 degrees, which is 2. So now you have to be careful because you have to take into account the sine though, okay? So this is the reciprocal of cosine. And so if cosine's negative, so is secant. Secant will be negative. So in this case, my answer should be -2. Okay, and you can see it's the reciprocal right here. Oops, sorry about that. You can see that it's the reciprocal of -1/2 right here. Okay. Um, so anyways, this will be something that'll be useful more than just this first exam, and you'll get pretty good at it, so we can fill it out probably in about 10 minutes or so. Um, but like I said, then once you fill it out, you should be able to kind of go through some of those questions fairly quickly. And then right here, positive and negative, if you wanted to, you could go ahead and list which ones are positive and negative. So you could have had it already listed that, oh yeah, cosine and secant are negative. So um, and so anyways, hopefully this video helps.